Our group consisted of 2 programmers from CDM and a programmer from SFU's undergraduate computer science program. Our team also consisted of 2 UI and UX designers and a project manager. The project aimed to translate an existing desktop application into a Microsoft HoloLens application for the BCIT Aircraft Maintenance Engineer program. The existing 2D desktop application is an interactive 3D model of an Airbus AS350 helicopter rotor that can be accessed through a web browser on a computer or a tablet. The user is able to manipulate controls to affect the rotor. The collective pitch of the blades, the cyclic pitch of the blades, the speed of the rotor, visibility of the airflow, and display controls could all be manipulated to help students understand what these controls do to the flight dynamics of a helicopter. HoloLens is a relatively new technology that enables users to experience interactive 3D digital sound and graphics, or holograms, overlaid onto real-world space. In the broadest sense, the problem we tried to solve was onboarding a client to a new technology, namely Microsoft HoloLens. A secondary problem was developing a HoloLens application and discovering the unique UX and UI considerations in working with HoloLens and holograms. A tertiary problem was to explore the use of a multiplayer function in a HoloLens experience. Our development process started out with research. The tech team engaged in research on HoloLens deployment, the import of assets, and how to program interactions. The UX and UI team studied what work had been done previously and researched best practices in designing holographic experiences. The team created an MVP, or minimum viable product, within the first 2 weeks of the project start by importing the existing assets and layout into a HoloLens application. The MVP was tested and user feedback was captured to create a backlog. The backlog was groomed as a team and new prototypes were produced and user tested in bi-weekly intervals.
Welcome to the Airbus AS350 helicopter rotor head simulation. This application is part of a larger BCIT project titled Effective Mixed Reality Practices for Teaching and Learning. The application was created in partnership with BCIT and the Center for Digital Media. You can use voice controls. The voice command menu can be found below you at your waist level. Use your head to move the gaze cursor to the menu, and the commands will pop up. For example, if you say, "Make bigger," the rotor will increase in size. If you don't remember what to say, you can always look down to see the voice command menu.
Make bigger. Make bigger. Make faster. Make faster.
The final solution proposed a very clean UI that incorporated voice controls instead of menus to encourage 3D viewing and movement around the rotor. UI elements were positioned out of the direct line of sight of the user or presented as translucent to give the main rotor presence. The team worked very hard to polish the tap and drag interactions necessary to manipulate cyclic and collective controllers.
Make smaller. Make smaller. Show airflow.